All right, can you hear me, first of all?
Yes.
Make sure. All right, great. Well, hi, everybody. Thanks for listening. I'm really excited to be here to talk about an experiment. Actually, this is a bit of a reprise of some of the talks that were actually shared on Monday from one of our hosts and a couple other folks about this big test that happened in the late summer of 22 at the Glenn Extreme Environment Rig, or GEAR. If you can go to the next slide. I'll give you a quick introduction of what VFOX actually is. I probably don't need to tell you much about GEAR, considering the talks from previous days, and a little bit about the run, a little bit about the results, and what is happening ongoing. So next slide, please. What is VFOX? VFOX is an oxygen fugacity sensor. Basically a small, similar to in principle to the oxygen sensors in the fuel system of your internal combustion car, assuming that you have one of those, to determine the partial pressure of oxygen in a gaseous atmosphere. In fact, it is an oxygen sensor in a car is designed for a hotter environment than the Venus surface, so we had to sort of redesign it for the Venus temperature regime. But basically, it's about the size of a shirt button. It has inside of it a standard, in this case, a palladium oxide standard, and is designed to, through diffusion of oxygen through the ceramic lid, determine measure through a voltage, the difference between the standard partial pressure of oxygen and the atmosphere's partial pressure of oxygen, and then you can calculate, therefore, if you know the standard, what the measured partial pressure is. And it's going to be attached to the outside of the Da Vinci mission's descent sphere, so that it can experience the descent through the atmosphere and sniff out the partial pressure of oxygen in the lower atmosphere. Next time step. So VFOX is also an academic program. VFOX is the student collaboration experiment for Da Vinci. So even though we have a preliminary design for it, the sensor itself, the final design and its testing and its verification and its delivery to the spacecraft will be conducted by students, primarily at the Johns Hopkins University, through a multi-year process that will be ongoing through a series of academic courses. But I'm not talking about the collaboration right now. I'm going to talk a little bit about our test of one of our prototypes in GEAR. So next slide, please. Again, so we're trying to ask the simple question: what is the partial pressure of oxygen near the surface of Venus? And this gives you this plot to the right shows you a little bit about the regime that we're talking about and why it is important for understanding what the stable mineralogy can be on the surface of Venus. So on the bottom you have the potential range derived from previous measurements and thermodynamic calculations of what the partial pressure might be, and also sort of a range of mineral stabilities of what might be stable on the surface of Venus. Next time step. This direct measurement and this also helps constrain and can be bolstered by measurements of the other gases in the lower atmosphere, some of which will be measured directly by Da Vinci as well. So next time step. And again, lastly, knowing the partial pressure of oxygen gives you a key to what minerals should be stable on the surface, and that can vary quite a bit depending on what you start with and what the partial pressure of oxygen and presence of other gases are. So next time step. I don't need to tell you too much about the Glenn rig because previous talks have talked about it. However, It's important to know that it can maintain the basically surface conditions of an atmosphere of Venus in this giant 800-liter chamber, and it can maintain it through the input and boosting of gases from at the start, and maintenance of it during the course of a multi-day experiment. In this particular case, the experiment was a 60-day long experiment. Next slide. There we go. And so this is a view you may have seen in previous talks, a sort of more detailed view of the mineral samples that went in on this particular experiment. But the upper right corner shows where VFOX actually was located in the chamber itself, sort of above the table of mineral samples, and a little bit adjacent to where gas influx and the gas boosts were input during the course of the experiment. On the bottom, you sort of see the setup of where the sensor, of how the sensor was put into the chamber, and how that feed through went through the for the measurement of the voltage, went from the internal to the exterior. This is, again, we rode along with this giant mineralogy experiment led by Marty Gilmore, and all kinds of results will be forthcoming from that experiment. It's actually quite exciting. I hope that you had a chance to catch some of the earlier talks talking about that. Next slide, please. These are the initial values of gases at the start of the test. And basically, we were trying to maintain this sort of recipe for a Venus atmosphere, primarily, of course, CO2, N2, but trying to maintain about 150 ppm of SO2 and reasonably consistent amounts of carbon monoxide, COS, H2S. And those three in particular were monitored by occasional sampling with gas chromatographs. I don't have those. I have a couple of measurements of those, and I'll tell you a little bit more about that, those results in a moment. And on the left, you sort of see the duration of the experiment across the 60 days over the summer. Next slide, please. And this is sort of a quick look at the beginning, the first test week, and how things were measured, what the temperature inside the chamber was, what the pressure maintained at Venus surface temperature pressure conditions, and sort of the SO2, CO2 measurements of the chamber. And if you go to the next slide. This is the response of the voltage measurement of the VFOX sensor during that initial heat up period. So in this particular case, the temperature is tracked in this purple line as we went to Venus surface conditions. And the voltage of the VFOX sensor is basically this small negative voltage in millivolts, the green line sort of measured. And what you see, this flat line as we get hot, is the gain setting on the readout was set to go from plus or minus 250 millivolts, and so we max out during as we get hot, but then we come back into our measurable range as we approach Venus surface temperature and pressure. Go to the next slide, please. This is kind of a zooming in on the heat up, and looking at our millivolt signal as we pass sort of higher temperatures, going up to 250 degrees Celsius. It's almost like we're descending through the atmosphere, and this is sort of before the real sensitive range of the sensor is kicking in, but we are getting a small change in the reading, and this is one of the things that we need to sort of figure out what is actually happening there. We aren't. This is sort of like too high in the atmosphere equivalent for us to think that the measurement is reliable, but these are things that we need to understand in order to figure out what the sensor is actually able to tell us deeper in the atmosphere. So next slide, please. This is as we reach Venus surface temperature and a more stable as well measurement from the VFOX sensor. This is like being in the descending through the deep atmosphere, and this is the kind of measurement that will be most critical for us as we try to simulate what VFOX will actually see as it descends. And so there's a lot of work to do here, and we've just begun to scratch that surface. So I'm not going to talk about this right now. I'm going to talk a little bit more about what happens once we have reached the final temperature pressure of the chamber on the next slide, and stay there for 60 days. You can tell that the voltage measurements stabilizes. It's a somewhat noisy signal, but it is still very stable in that in its ultimate measurement. Go to the next slide. As time passes, this is actually the first week or so of the experiment. There are several boosts of gas because there's a lot of stuff happening. We've just established this Venus temperature pressure, but there's a lot of other stuff in the chamber, right? There's a bunch of minerals, there's a bunch of stuff in the chamber that needs to sort of settle down and stabilize. So this signal is highly variable over the first several days of the experiment, and there's a lot to figure out of what's going on. These various M1, M2, M3, those are where gas chromatograph measurements were taken of other gas constituents. Next slide, please. This is also where the boosts of the gas were over the course of the first week. But things stabilize quite a bit in the next slide. As we go further along in time, the signal from VFOX actually stays quite consistent. And whenever we boost gas and put in more SO2, because the stainless steel chamber and everything else inside the chamber is sort of sucking up the sulfur dioxide, as the experiment continues, every time there's a gas boost, there is a spike in our signal. And basically that when you put in SO2, the gas equilibrium is disturbed and then sort of returns to normal or a more normal state as time passes. So this is like several days of time where there's a gas boost each day. On the bottom, you can see the measurements of SO2, H2S, and the presence of water. Those numbers aren't really meaningful, just that the fact that there is some water in there in the chamber. And these are, again, early measurements, and we've done a little bit more analysis since then, and we'll continue to do so, which we'll be presenting in LPSC. And I'm going to speed on, continuing to the next slide. Later,
finish really quickly here. Sorry,
just about almost finished. Later on, we see things stabilize again to a very sort of stable signal. Next slide. And I just wanted to show you, this is how the SO2 is maintained, but that's moving on to the next one. I want to show you just very quickly at the end of the test, when everything was taken out, the electrode, this platinum electrode on the top of the sensor, you can see was subject to sulfur chemistry. That's sort of platinum sulfide dendrites that you see growing off of the signal. So interestingly enough, it didn't really change the signal that we got from the throughout the test, but it is something that over 60 days you can see sulfur chemistry definitely happens on exposed materials. Next slide might be last. Yes, so we're just continuing this ongoing analysis. We'll be matching up our results with the mineral standards that were also in the chamber, and I will have a lot more to say at LPSC. So I will end there.